So good afternoon or good evening everyone. This list of videos is going to be about how to program in Java or object-oriented programming in general. And all these videos are not going to be scripted in any way, so if I do make any mistake, please to notify me in a way so that I can fix it, rectify it. So in today's topic, we are going to talk about object-oriented programming, the definition of it, and also we have a little short review about all the types in Java that we need to know of before we can move into the subject as a whole. And essentially for this video, first, let's just start out. We're going to talk about why should we use object-oriented programming. Object-oriented programming, also known as OOP, or should I say OOP, is a way that we can essentially make a thing in our code that essentially resemble an actual object. So for example, an object like a car, it got a wheel, it got the whole seat, for example, it got engine and stuff. These are objects, and these are essentially attribute of that object. And object-oriented programming is essentially work like this. You're basically declaring something as an object, and then you have attributes that revolve around it in a way. And with this kind of programming, we can essentially create a more proficient tool for the user, and also we can in some way improve our design to make our code more robust, more maintainable, more extensible if you do want to add anything after the code has been done. And you can also make your code more understandable to your human fellows and not aliens. Next, we will talk about data type. Data type in Java are how should I say? You have multiple data types in Java, like many other language. You got int, which are integer. Int can be 0, it can be 1, it can be 100 million. Those are int. And essentially int are values which are integer, and I hope you do remember it. Next we got another variation of int, which is long. Long is essentially the same as int, however it can contain more number comparing to int, which is there. For example, you got like 10 to 1,000 bazillion, something like that. And then we got another variant of int, which is like short. So short got a shorter range with the integer that we can, well, essentially use. So with int, we can use from somewhere around 2 billion numbers in that range. So from 2 billion something over here all the way, wait, 1 billion, yep, all the way to -2 something billion over here. And with short, we can only have around 32,767 number in from this to this to the -32,767. So the range is a lot smaller comparing to int and long. And with long, you can even go up till 9 undecillion, I reckon. I don't remember the correct measurement or the correct like the numbers that long and yeah, long can have. So I might be incorrect somewhere. And then again, this video is not scripted in any way, So do feel like notify me if I do make anything in this video that is, well, make you feel a little bit unsatisfied in a way. Next one we got byte. So what is byte? Byte is essentially the size bit, and it can contain all of the number, but only from the range of minus 128 to 127, which is like the lowest one. And for car or char or character, you essentially assign it to a character. So you got A, B, C, D, E, something like that. Character. And a string is essentially an array of characters, in case you don't know. The more you know. Right. So next up, we got mm, int, long, short, byte, char. And now we will go on to other floating point number like float and double. So double can be more precise than float in a way, and it can allow you to use essentially more number with double, like around 1 billion, a zillion, things like that. And apart from these number, character, byte, essentially number type or character, we also got another type which is boolean. So with boolean we can only have two value, true or false. And boolean value is the most important value out of all. For example, for if statement, for conditional statement in Java in general. Alright. Oh, copy. Ah, silly me. Alright, so now moving on to the next one, we need to know how to assign values. So as I mentioned earlier, as we got a primitive value, so now we need to know about a reference data type. A reference data type can essentially be an object. So for example, if you get a string, it's also uh, an object and a reference. Or you can have, I can have an object named item, the class is item, and I can have many objects. For example, this one's going to be an orange that can have some kind of value in here. And if I want to use it, I would use this one to refer to the object on this side. So this one is just for reference. The actual object is going to be on this side, the right hand side. So if you want to have, for example, another variable that you can call it tangerine or something, then if you're going to say it equals to orange, it would only link this reference to refer back to the same object. It does not create a new object for tangerine. So let's talk about it in a more abstract manner. So imagine you create an object A, this is object A itself, and you allocate it a memory of some sort. So when you call A, you actually refer to this one. So you're referring to the object A itself. And if you have B and you say B is equal to A, essentially you just create another reference that refer to this one. Another more human example of this is like, imagine you're a human. Cool. So human in this term is basically analogy for the object in Java. So you're a human and you got a reference which is your name name essentially, which is A, and you got B, which is like your nickname. I mean, like if people can still call me, for example, Kevin, I would still be able to listen to them, hear them out, things like that. So it's just another way to refer to an object. That's not a way for you to create a new object to assign to it. So if B equals to A is actually another way of calling the same A object with a new name, essentially. Like calling your friend with a nickname and not their real name. Alright, so however, with primitive type, when we actually used, for example, A equals to 2, B equals to A, then it's actually assigning the value. So it's actually take the value of 2 and assign it over here, so that B now is equals to 2, not reference for 2, but it actually got a value 2. It does not refer to the old 2, which is going to be an A, but it's actually got an add value, which is 2. Alright, so let's move on. So imagine now we are going to create an object. So imagine that you're a student, and as a student in UW, you would need to have your student ID, your name, you need to know your age, your current command course, your anything, essentially anything. And then all these are attribute. So these are attribute. And to access those attributes, we need to have methods. And there are two types of methods that we need to know about in Java. And those are, first we got accessor. As the name implies, they access a certain attribute inside of an object. We can also call this getters. Next one, we will have something called mutator. Mutator, as the name suggests, again, it mutates, quote unquote, mutates the attribute that we already got over here. It essentially changed the value of all the values that we're currently having. Another way of referring to mutators in Java is the setters. You can also call mutators setters, and essentially people will get you. Alright, so for a student, you can also have get name, for example. This one is successor, and you got set name for setting the name if you do want to change your name, and this one will be the mutator. This one will essentially be the accessor. Alright, so after all those, let's talk more about the object itself, which is going to be a student. So if we do code out this one, then it would essentially look something like this. First, I need to save it, which is going to be in here. So first video.java. So with this video, I'm gonna create a public class called first video, and essentially with this one, I'm gonna create, oh, it's not going to be first video. Oops. So with this one, I'm gonna put the main method into it, which is going to be this. Alright, so we can interact with the object through this main method, and with all of the classes that we need to have, the main method is the main class, or the class that contains the main method is supposed to be exist in every single Java program ever, because it's essentially an entry point for your program, and if you don't have it, you will have a compilation error. not runtime error. And with that, you would not be able to run your program. So before interacting with anything, we would first need to create a class called student. And with this class, we will have attributes such as student ID. We can also have name, as we previously mentioned. We can also have our age. We can also have our course that we're currently enrolling, and with age you can also use type int and not string if you don't want to have any data type conversion. I mean, like, essentially it's more logical in that way, because age is often relates to an integer, so I cannot be 2.5 years old. But yeah, so now with every object you would essentially got things like getters, which are going to be methods or functions that can return value at the attribute inside of the object itself for you to use in many other objects. So with this one, we can have get user ID. I'm gonna make multiple copy of it. So this one is going to be get name. This one is going to be get age. This one's going to be get course. And with age, you need to return the data type that is actually correspond to what you have inside of the student class. So with age, its data type is int, so you need to return data type int in here. And more often than not, getters don't need to have any argument, or should I say parameters. And in here you would essentially just type return this dot student ID, and this is actually referred to an instance of an instance of class student. So if I do create a student in here which call Kevin, and this is a new student that have values such as 0000069. My name is Kevin. I'm 19 and I'm currently doing an bachelor in comp sci, things like that. So this is actually an object and you need to know about it. Also, for example, with this one, it will be the same as student ID, so you will return this dot name. So essentially, whenever you call this, this is actually referred to the object or the instance that you just create from that specific class. And if I want to use this function get name, I would actually use Kevin dot get name. And essentially, this over here is referring to Kevin over here, the instance of the class that we create the object from. And with get age, you would do the same thing, return this dot age, course, same thing, return this dot course. So we are basically done with the getters. Now we're going to move on to the setters, which are going to be the mutators, if you want to call it like that. And essentially I'm gonna make a copy of it, and usually setters are set to be void in any case because they don't modify any of the value inside. Nope, they don't return any value inside of the object, but rather they modify the value. Sorry, I got it a little bit confused confusing there. So essentially change all this to set, and with this one, if we want to change value, we need to pass parameters or arguments into it. And with this one, we can essentially have string new student ID, for example, and we can replace this that student ID equals to new student ID. It essentially takes the value that you pass in as parameters or like argument and change the student ID inside of the object itself. If we're going to do the same thing for name, so we got string new name, then we can assign new name to the current name that is going to be inside the object itself, which is going to be new name, and this is actually referred to the object of the new name because string is a reference type, not a primitive type. One more thing, with age we need to be int, so int new age for example, and if we want to assign new age, it would be new age. This dot age equals to new age. I'm going to do the same thing for course to cut down on time. So we have new course, and this dot course is actually equals to new course, which is basically the value we just assigned to that specific course. Alright, so we have already done with all of the getters and setters, accessors and mutators. Alright, but we don't have any constructors. So what are the constructor? Constructor is essentially a way for you to gather all of the information that the user pass in to create an object with all of those value that the user pass in as argument. So for example in this one, if I don't put any constructor inside of here, the student object itself, Java would actually create a default constructor. And with the default constructor, it would basically initialize the value for the 4 attribute that are already created over here, and it would assign values such as boolean, it would be false, data type like int and stuff, it would be 0, or with reference type like string over here with student, it would actually equals to null because they don't have anything to work with. They don't have the name Kevin to work with. That's why we need to explicitly create a constructor. So a way to create a constructor is to use public student, which is public the class name itself, and then you can pass any parameters into here, like the name, the parameters that you're going to use. So to me, I will use string.studentID to pass in the student ID, string name, int age, string course. And with this one, inside of this constructor, we would essentially assigning all the values that we got from this list of parameters or arguments and start assigning each corresponding value to each of the attribute we got inside of that object. And with this one, we got first this dot student ID what equals to student ID. We use this over here, which is basically a way for calling the current object that we are creating to have the student ID. And if you don't put anything into here, Java would not be able to understand because we already put student ID over here, which is a really bad way to program. Yes, I know. You can change it to, for example, ID, which is another way, but since I want to keep things simple and easy to follow, I'll just put it student ID, and here I put this dot student ID. So on the left hand side you got essentially the attribute, and on the right hand side you're actually referring to the parameters in order to get the value. So now we're going to do the same thing. So this dot name would equals to name, this dot age would equals to age, this dot course would equals to course. I just created a constructor, a parameterized constructor because it takes in parameter. Sorry for any pronunciation errors that I've made. I'm sorry, I'm not an English speaker in this country. A fluent English speaker. Mm, great. So a default constructor, like I previously mentioned, would actually initialize the default value for all of the attributes that we got inside of the class. And since we already explicitly designed a constructor which is a parameterized one, Java will not create that default constructor anymore. And if you do create an object without passing anything into it, it will return an error because it cannot find the specific constructor anywhere. That's why we need to create another type of constructor, which is a no arc or no argument constructor, or a no parameters constructor. No par or no arc. It essentially the same. So public student, and you got nothing inside of the parameter list over here because you don't want anything. So if you do have nothing in here, then you would not have to worry about it, because like this. So it will just initialize any value that you already explicitly designed inside of here. No argument parameters, and no argument constructors and default constructors are the same. However, the thing that differentiates the two is the fact that with a no argument constructor, you can actually assign it to a default value of choice, which is going to be anything. So instead of referring to a student ID as null, I'm going to refer to the student ID. It's going to be not available. And this dot name, which is going to be not available too, because I haven't passed anything into it. And with this dot age, I would put it to 0, which is essentially like what the default constructor is going to initialize the value for. And also last thing, we got this dot course equals to not available. Alright, so with this one, I'm just gonna try to print out my name. So with print line, we got the thing over here, which is not going to be a string. Actually put it in. So name, my name is going to be Kevin dot guess is going to be get name. Yeah, we are using an accessor or a getter to get the name of the object, which is going to be Kevin. And if I run this code, if I do, it will essentially create a line of text that said name dash Kevin. So first video.java, Java, first video. Yep, see, name not available. Why is it not available? It's not available because we didn't even pass anything into the constructor itself in order to initialize the name. That's why it would choose to have this constructor in order to initialize the value for the object Kevin. So if I do oops, get name, if I do return my value into here and rerun the code, it will actually return Kevin because I pass in Kevin. So it would call this parameterized constructor instead and assign the name Kevin to the attribute name inside the class student, so I can get my name. So what if I want to get my age, for example? And it would be age. Yep. Compile the code, run it again, and it should give age equals to 19. Hooray! So those are the essential and probably the most important thing about object, most basic thing. One more thing to note is that can you see anything over here that is weird? So you got all of those private, public, and kind of stuff. So public and private over here, or protected or default, in many cases are access modifier. And an access modifier is essentially a way for you to limit the access of other classes to that specific element. So for example, if I put private over here to this element, it would essentially create this element and render it unusable outside of the class student. It can only be used inside of the class student, and if you try to access it outside of the class student, so for example, if I go like um, example Kevin dot student ID like this, it would return an error because student ID has private access in student, and since it's got private access, other classes, like for example in this situation first video, cannot access this specific element, which is student ID. That's why we need to use getter or accessor to access this kind of information. However, if I do put this to public, it would be different. You would be able to compile it and you would be able to actually use it because this is public, and a public attribute or a public variable or class or anything can be accessed in other classes or method, or essentially everything other than the current class that the element reside in. Alright, so anything else that I need to say about? One more thing that you need to know about data type that I forgot to mention earlier is that you can only assign a value of the same type to a variable. So if you do declare int equals to 2, it would going to work, but if you're going to declare double, not double, but um, so normally you would have in x equals to 2 and this won't work. If you declare the same thing, oh my god, if you declare the same thing, which is going to be int, for example, y equals to 2.0, it would just return an error because it cannot promote itself. The data type is here is int, and here you got double, and you cannot make a y which has the data type of int to have a value of double. However, it can work the other way around, which is going to be double. For example, you got z or z. With z, you can assign it to be 2, and it will still actually work because it can auto promote the value over here to actually match the one over here. So auto promotion in Java is actually weird if you don't know how to use it. Auto promotion is essentially like this. Oh, I cannot. But essentially, you would be able to. Um, here I have byte, short, and character, long, float, double. So I'm gonna use green for this one, which is going to be promoted. So if you use a value byte for a short data type of variable, it will actually got promoted. Same go for if you use a short value for an int variable, it would actually get promoted. Same would go for this one. So the green line would be promoted and the other way around it would not be able to, or lost in conversion. Sometimes you do get that, and if you don't know how to handle it, it would actually be a pain because you obviously would have no knowledge whatsoever about the data type. So for example, if I go it this way, it would not be able to because we got loss in position. Even though like if you got 2.4 like this one, it cannot go back to being 2 because it would lose this part, which is going to be loss in precision. Same goes for double or long. Yeah, so that is one thing to know about Java, that it auto promote the data or the value to match the data type, and you can only assign value of the same data type together. Alright, so I think that's it for this video, and in the next video I'm going to talk about inheritance, which is going to be the first characteristic of object-oriented programming in general. And a sneak peek for it, inheritance is essentially, imagine it this way. So you got okay, clear this one. Yep. So we got, for example, we got a vehicle. A vehicle is like a class itself. Cool. And then we have another object down there that extends it, which is a subclass of it, which is going to be car, for example, motorbike. Yep, these two are subclass, and it inherits all of the traits, all of the attributes that you declared in vehicle, because you consider car and motorbike to be vehicles in general. Cool. So car and motorbike got all the traits or attribute of a vehicle, and inheritance works in the same way. It's like any subclasses whatsoever that inherits all the attribute from the parent class or superclass or just the class above of it, essentially. And you can have also multiple inheritance. So your car, you got, for example, sedan and ute, for example. And a sedan will actually inherit the attribute from the car itself, but it can also inherit all the attribute of a normal vehicle. So yeah, that's how inheritance work. Alright, I'll see you guys next video. Thank you for listening, and hope you can bear with whatever I said, and if I do make any mistake, I'm sorry. This is the first time I made a video, and I hope that you guys can catch something in the video that I try to explain. I'm not good explaining either, so hopefully it can help you guys in a way. So thank you for listening to me, and hopefully you guys will support me next video. Bye.